Hi, in this video I would like to tell you how to solve this kind of exercise where we have to do a DNA dilution. So the exercise says a DNA fragment of double-stranded DNA is 100 base pairs. What mass do I need to put into 1 microliter of water to obtain a final concentration of 1 mole per liter? What about 1 microliter of water? And the hint is that the molar mass of DNA is 660 gram per mole per base pair. So to solve this kind of exercise, the first thing that we need to do is to know the molar mass of the DNA fragment. And the way we do this is quite simple. We start by just saying that we have a molar mass for every base pair of 660 gram per mole per base pair, and because we have 100 base pairs, that gives us a total of 66,000 gram per mole. And this here is the molar mass of the product of 100 base pairs. Another question is, how much of that do I need to put in 1 liter of water in order to obtain a concentration of 1 mole per liter? So the important thing is to realize that this here above just tells us that 66 kilograms of that particular piece of DNA is equal to 1 mole. So if I want to put 1 mole per liter, then I need to put 66 kilogram per liter. Okay, that's very simple. It says that 1 mole per liter is equal to 66 kilograms per liter. And so that answers the question. If we go back to what it was, so what mass do I need to put in 1 liter of water to obtain a final concentration of 1 mole per liter? And then the answer is I need to put 66 kilogram in 1 liter of water in order to obtain 1 mole per liter. And then there is the other question, which is a variation on the first, which says now if I have 1 microliter of water, how much DNA do I need to put to have the same concentration? And so the way we solve it is that we say that 1 microliter here is 1/millionth of a liter. Okay, that's the meaning of the symbol micro here. And so if I have here a relatively large volume of water, that makes 1 liter. Then I need to put in this volume of water 66 kilograms. But if I have a much smaller volume of water here, which is 1 microliter, and if I want the concentration to be exactly the same, if this is 1/millionth of the total volume, then inside there must be 1/millionth of the total mass. Okay, so in order to have 1 mole per liter in 1 microliter, I need to put 66 kilograms times 10 to the minus 6 kilograms here times 10 to the minus 6. And this is 66 milligrams in 1 microliter. So if I put 66 milligram in 1 microliter, I get the same concentration as if I put 66 kilograms in 1 liter. And that's the way I solve these problems. So to recap, the first thing I do is that I get the molar concentration of the product I'm interested in. That's the product here of 100 base pairs. Okay. The second thing I do is I'm computing the amount of DNA that I need to get to this standard concentration of 1 mole per liter. And that's super easy to compute when I've got that here. And once I get this, I take a no-nonsense approach. I make a little drawing here that tells me that in order to have the concentration here in 1 liter, which is not very realistic for DNA, then I just need to divide by 1,000,000 in order to get the concentration in 1 microliter. And that's the way I go step by step to sort the difficulties of having to deal with products of different sizes, and then dealing with different concentration, and then going to the particular volume, which would be 1 microliter in this case. So I hope this helps, and I hope that this helps you solve the question in the quiz. So good luck with that, and see you soon for the next lecture.